Aluminum bromide. Aluminum is +3, bromine is -1. So we have AlBr3, and that's all they give us. So this has to be a decomposition because we have one reactant. It's a binary decomposition because we have two elements, aluminum and bromine. Will decompose into A plus B. Well, A is aluminum and B is bromine. Now I have to think about Hofbrinkel because I have elements. Aluminum is not a part of Hofbrinkel, but bromine is, so we'll need to put a 2 there. Notice that the subscripts are not the same, and they are typically not the same, so we have to balance it. Well, we have 1 aluminum and 1 aluminum, 3 bromines and 2 bromines, so we're going to make them both 6. 2 times 3 is 6, 3 times 2 is 6. By putting the 2 here in front of aluminum bromide, I also have 2 aluminums, so we'll have to put a 2 there, and we're balanced. Copper 2 carbonate. Copper has a charge of +2. Carbonate is CO3 -2. So we cross our charges, Cu, CO3. Since that's my only substance, it has to be a decomposition. So we have a metal carbonate. So I'm looking at my decompositions, and I'm going to follow the metallic carbonates. So 2B. MCO3 decomposes into MO, which would be oxygen, plus CO2. Well, the metal in this problem is copper, and copper had a charge of +2. Oxygen also has a charge of -2, so that would reduce to CuO. And then I would just copy plus CO2. You would have to balance it then. 1 Cu, 1 Cu, 1 C, 1 C, 3 oxygens, 1 plus 2 is 3 oxygens, so it is balanced. Barium hydroxide. Barium is Ba plus 2, hydroxide is OH minus 1. Cross your charges, BaOH2. So I look at my reference tables. This is a metallic hydroxide, so I'm following 2D. The metal hydroxide decomposes into the metal oxide plus water. So barium has a charge of +2, oxygen has a charge of -2, so that would be BaO plus H2O. 1 Ba, 1 Ba, 2 oxygens, 1 plus 1 is 2 oxygens, 2 hydrogens, it's balanced. Potassium chlorate. Potassium is K plus 1. Chlorate is ClO3 minus 1. Cross your charges, KClO3. So in my reference table, I'm going to follow along with the with the metallic chlorates, which would be 2E. MClO3 decomposes into MCl plus O2. So my metal is potassium. Chlorine is -1, so that's KCl plus O2. To balance it, 1K, 1K, 1Cl, 1Cl, 3 oxygens, 2 oxygens. 2 times 3 is 6, 3 times 2 is 6. By putting the 2 there, I now have 2 potassiums, so I'd have to multiply by 2, giving me 2 chlorines and 2 chlorines. Carbonic acid, it's an acid, so it has to start with hydrogen, which is +1. Carbonic would refer to carbonate, CO3 -2. So you would cross your charges, H2CO3. Because it's an acid, we're going to follow along with the oxyacid decomposes. So this is 2F. You have the acid decomposing into the non-metal oxide plus water. Alright, so if I have plus water, what does that leave me with? The non-metal then is carbon, and that leaves me with 2 oxygens left, so it has to be CO2. So 2F and 1C are the opposites of each other, and they're always balanced if you write them properly. Number 6, potassium is K plus 1. Hydrogen carbonate is HCO3 minus 1. It's a polyatomic. So we have KHCO3. So looking at my decomposition, I'm following the metallic hydrogen carbonate, or 2C. So MHCO3 would decompose into MO plus H2O plus CO2. Well, my metal is potassium, and oxygen has a charge of -2, so I'd cross my charges and get K2O plus H2O plus CO2. So to balance it, I would want to start with my potassium. 1K, 2Ks, I'd multiply by 2. That gives me 2 carbons, so I'd come over here and multiply by 2. That gives me 2 hydrogens, 2 hydrogens. 6 oxygens, 1 plus 1 plus 4 is 6 oxygens, and it's balanced. Combustion reactions always start off as